All right, new day and another laptop that needs to be saved, and this time we have an Alienware X15R2. This is probably a 2022, 2023 model, very new machine. The customer said that they are having an issue with it coming on. It doesn't power on at all. They bought a brand new battery and it doesn't even power on with that. So I haven't taken a look at this yet, so let's take a look together and see if we can get this figured out. All right, the first thing we're gonna do is just see if it turns on. We're gonna hit the power button, and we are getting no power. So let's plug in the power meter, plug in the charger, and see if we get any current draw. So when I plug in the charger, we're gonna look here. I see that it pulled 0.01 for 1 second and then turned back off. I'm gonna do that one more time. I'm gonna unplug it, plug it back in, 0.01 and then 0. What we actually want it to do is actually go up to 0.02 and sit there. That's gonna be 20 milliamps. That just means that the EC chip, the embedded controller, is coming on and running its loop of code and looking for any key presses and stuff. So the other thing we're gonna test is I just wanna see if when we open and close the lid, it should actually trigger some sort of response there. For the Hall effect sensor, I'm gonna hit the power button, see if we are getting any current draw at all, and we're not. So the fact that it's sitting at 0 could mean there's a short on the board. There's a few different scenarios that can happen with this machine. There is liquid metal on the CPU, and so liquid metal could be leaking somewhere and causing a short. It could just be like a burned out component on the board or something like that, a shorted capacitor. But the fact that it's going to 0.01 first and then going down to 0 usually means that I don't think there's a short on the board, but we'll see. Let's open it up and take a look inside. All right, and the bottom is off. Oh my gosh, I love this model. I love this design. It has 4 fans in it. Look at this, 1, 2, 3, 4. CPU and GPU both have a pair of fans. There's a pair of NVMEs right here in the middle. Main battery, it is an OEM battery. Like I said, this machine isn't even that old. It's a 2022, 2023, something like that. This is probably gonna have something like a 3080, 3070 chip in it for the GPU. But what we want to see here when we're testing this is I'm going to plug in the power and let's measure right here in the power input and see how far the voltage goes before it stops, because we could have some sort of issue with the power management chip, or we could have an issue with the DC jack or even the EC chip or something like that. The thing is if the customer replaced the battery and the battery had charge, it should power off the battery even if the power management chip is bad. So that's kind of like a way to test. But let's get under the microscope. All right, so here's where the DC jack plugs in the motherboard. I'm gonna go ahead and plug in the charger into the laptop, and then we can measure the voltage here at the jack. And we are getting our 20 volts to the motherboard itself. It's gonna go through these inductors here, and then it's gonna go through a pair of MOSFETs. Well, maybe it's only one MOSFET. Let's see, does it go through this one? Yeah, so it goes through this one first, and it's gonna come out of this one. And we aren't getting anything out of the first MOSFET. And then it would come through this one again, through the second MOSFET, and then it'd come to the main power rail, which is right here, okay? And this is gonna be the current sense resistor for the main power rail. The way that these laptops work is they need to figure out how much current is being pulled or used. And so this low resistance resistor is a current sense resistor, and that's what the power management chip is monitoring to make sure we don't have a current overflow. Well, we're not even getting voltage that far, right? So we have voltage here, and then right past this, it should come through here, and it's turned off. So this chip is turned off right here, and the power management chip is telling it to turn off. Why is it telling it to turn off? Is it because there's a short? So I'm gonna unplug the charger from the motherboard. So now we have no voltage in the board. Actually, the battery's still plugged in. Let me unplug the battery. We only wanna measure for resistance with no voltage in the board. So battery's unplugged. So now we're gonna put our meter in continuity mode where you touch the probes together, it beeps. I'll put one side on ground, which is right here. And we just we'll test to see if we have a short. So we obviously didn't have a short here because we had 20 volts. But on the output of this, do we have a short? Nope. And then that comes into this one, and then it comes out of this one. And do we have a short? There's no short, okay? So this is the main power rail, and we do not have a short on the main power rail. So this is good news, right? Good news and bad news, right? Because why are these told not to come on? Is it because there's an issue with the power management chip? Let's plug the battery back in. I want to see how much voltage we have on the battery. If we have full voltage on the battery, then we know that we have some other issue. And we have 10.9, that's a little bit on the low side. 11 volts is probably gonna be on the lower side, but it should be enough to have it come on, I would think. Let me measure the main power rail right as I plug in the charger, okay? So we're measuring the main power rail right now. And then I'm gonna plug in the charger and see if it momentarily jumps up to 20 volts and then shuts back off. And it does, okay? So this is a symptom that is telling me that we have an issue with our EC chip, okay? So what's actually happening is right when we plug in the charger, these MOSFETs momentarily turn on, and it turns on all the power rails on the board that are supposed to be on whenever the machine's off, right? So we have the 3.3, the 5 volt, and the 19 volt or the 20 volt main power rail. It turned those on momentarily just to test them, shuts them back off, and then the EC chip is in charge of that. So where's the EC chip? That's gonna be this chip right here. This is an E&E. It's the KB9542GF. So what this chip does is it's an embedded controller, runs a loop of code, kind of like an Arduino or something. It has GPIO, general input and output pins, that are tied to your power button, the keyboard, and it'll even run like the Hall effect sensor for the screen. There's a lot of different things that hooks to. So each machine's a little different. This one has a lot more things hooked to it. But the one thing about it is, on this particular machine, the chip is programmed whenever you do a BIOS flash. So you have a BIOS chip that runs the board, that starts up the board, but this is actually what turns on the board. And this has its own BIOS flash. And if we have an issue with the EC chip, then we won't be able to, oh, is that a burn hole? It looks like a burn hole right there. Then if this EC chip is bad, the machine won't turn on. And that looks like a burned EC chip. So we could have a burned EC chip based on that right there. That little dot. And so if this EC chip is bad, then this is catastrophic damage to this board, okay? Most of the time, people would just say that that's the end of this board altogether, because what you have to do is you'll have to replace this EC chip with another one, which are obtainable. I have some. But the EC chip's gonna be blank because this board doesn't automatically program those. So what we'd have to do is actually end up programming them. Luckily, they do have program headers right here, and I do have a programmer. So if it is an EC chip issue, then we will be able to replace it. But we're gonna have to pull this motherboard out. I wanna go ahead and test everything first, and we also wanna do a physical inspection on the board before we jump to the conclusion that it is an EC chip. Because we could have liquid metal on the board, like I said, that's shutting itself off, and that could just be like some sort of speck on the chip. It does look suspect though, doesn't it? I don't know. Let's see if we can clean it off. Still there. You know, that definitely could be a burn hole, but we don't know. So let me get the motherboard removed and we'll continue testing. Okay, so I'm taking this little back cover off, and the screws that just came out of this back cover are not the correct screws that go here. These are actually captive screws that go in the base. So what does that tell me? It tells me that somebody has been in here. This is not part of their description. Let me see what their description is. The description says, won't turn on even with new battery. I also removed the battery and it still won't turn on. Okay, so they took the bottom cover off, but if the screws are changed in this little back cover here, that means they took this off too. Does that mean that they took the whole motherboard out at some point? Because the only time that I've ever seen a burnt EC chip is when somebody's been in here messing with stuff. So if we do have a burn here, they could have dropped a screw on here. I don't know if it was before they changed the battery or not, is my whole point. Because if they're saying, change the battery, and now it doesn't work, or it didn't work and then I changed the battery. So this might be a time for me to stop and call the customer. So I'll be right back. Julio, please.
Yes, I'm done.
Hey, Julio, this is Nathan with Parts People working on a laptop for you. How you doing?
I'm all right. Yeah, I was wondering about that.
Yeah, yes. So I've kind of noticed something. I just want to ask you a few questions so we can kind of figure it out. So you said you replaced the battery because the laptop wasn't coming on, or did you replace the battery and then it didn't come on?
No, it didn't come on. I think I know what I did. I was thinking about it. I was like, oh, shoot. I think I put in an external battery, and I think I put it through the wrong port.
Okay.
Maybe I burnt something out. I don't know. After that, I bought a new battery, and I put it in there, and it didn't work. So I returned the new battery, and I put the original battery back in.
Okay. And so external battery meaning like it was like a USB-C battery? Power bank? Okay. I mean, I'll look at that and see if there's a USB-C issue on the board. But what I'm looking at, the EC chip looks like it has a burn hole in it, which the EC chip is an embedded controller that actually is the startup chip for the motherboard. It looks like it has a burn hole in it. I don't know for sure if it is. The symptoms that I'm seeing are a bad EC chip. But usually these things don't just burn out. They usually burn out when somebody is in the machine, when there's still power attached. So like they opened it up and like was changing out the hard drive or SSD, dropped a screw on the motherboard or plugged something in wrong, but still had the battery plugged in the whole time. Like if you messed with it with the battery plugged in, do you think that that could have been a scenario that happened?
didn't start messing with the battery until it turned off. I brought my laptop upstairs one day, and I didn't bring my regular charger, but I noticed I had my power bank, and I plugged that in there, and I didn't even think about it, so I may have, like, did something, but then it just turned off.
Okay.
I was like, oh, okay, so maybe the battery died, and then I just kind of left it alone. And then the next day, I tried to turn it back on, and nothing happened, and that's when I, took everything apart.
Okay.
I did open it up.
Okay. Yeah, because I could see some screws in the wrong spot. And that's what made me stop. And I was like, okay, that means that somebody has taken it apart more than what they said. Because the back cover, the little rear cover plate, had the wrong screws in it. And so...
Well, I did take it apart once, and then actually, I gave it to my dad, who actually took it to Geek Squad at Best Buy, and they said they don't work with Alienware, but he took it apart.
Okay.
That time. I've always dealt with the original screws, so I don't know what happened since then.
Well, I'm just saying, like, the screws that are in the back, the back cover, the rear cover, are actually the ones that go in the bottom. Like, they're too long. They're actually in the wrong holes. That's all. So it's just that the screws are just kind of mixed up. They got switched. But anyway, okay. Well, that's the information I need. I'll continue. I'm going to probably end up pulling the motherboard out anyway. I'm pretty sure it is probably a bad EC chip, which I can access without pulling the board, but I want to make sure there's no other burnt components or anything else anywhere else, and make sure that all the rest of the power rails are coming up. And I'll give you an update shortly. All right, so there you go. So a little more information, talking to the customer or speaking with him. They did open it up. It has been taken apart completely, put back together. It's also been taken to Geek Squad, which they said they didn't work on it, so I don't really know if that means they opened it or not. So yeah, you never know exactly if you're getting all the information. But so at this point, it is probably going to be this EC chip because it does look like it's burnt. But what I want to do is I want to pull the board out completely, and I want to look over everything. I want to make sure that we do a physical inspection, make sure we don't have any burnt components. I also want to see that the 3-volt and the 5-volt power rails are coming up momentarily when we plug in the charger. If that is happening, then we know that it's just a programming issue or a bad EC chip. And so we'll just put a new one of those on, we'll get it programmed, and this thing should be fixed up, hopefully, right? So let me go ahead and get this pulled out. All right, and the motherboard is out. All right, so like I said, this machine has liquid metal on the CPU. This is the GPU side. I don't usually see the liquid metal leaking out, and I don't necessarily want to open this up because the liquid metal, if it's happy and applied properly, then we're not going to have an issue. So I'm just going to kind of look here and see, because we're not really detecting a short on the main power rail. And I don't see any leaking going on here, so we're good. I don't want to pull the heatsink off, but what I want to test, this is the 3-volt and 5-volt power rails right here. And if we plug in the charger and the 3-volt and the 5-volt power rails come up momentarily, then we know it's probably just an EC issue. So hold that down there. And 5.2, and then it shuts back off. So now we'll plug in it again while we're holding on to 3.3. 3.3 came up, and then it will shut back off. So we do know that now we don't have a short on the 3-volt, we don't have a short on the 5-volt, we don't have a short on the main power rail. And after discussing with the customer about what he had done and not done, because you never get all the information, and then the fact that we do have that little dot there, I think that we are going to go with a EC replacement with a programming. So it is a difficult task. Most repair shops would turn this down or not be able to do it, but guess what? We are prepared to do it. Let me make sure I do have some new E&E chips here. I have one. It's not even new though. It needs to be reballed. That's fine. So I guess we're doing a reball because I don't have any that are already pre-balled. So let me go ahead and get this one removed, and then we'll reball the other one and get that installed. Most likely this chip is a brand new chip that I had installed in another machine to test, and I just took it back off. That's probably what ended up happening, and that's why I just put it back in the bag there. So we're gonna put a bigger tip on this. We wanna make sure that we heat the board enough. All right, so these EC chips are BGA, so they are a little bit harder to get off. These boards are really thick, and we wanna make sure that we get it off properly. Is that, I don't know if that's a burn hole. No, I just scratched it off. That's funny. It didn't come off with alcohol, so I'm not convinced that that's a burn hole. So I don't know. But I think we still have an EC issue. So let me just start by reprogramming this EC, because it's it's a pain. If we have to pull this EC chip, reball the other EC chip, put that on there, and then program it, that's a good amount of work. But if we just try to program this, because I have seen these things get corrupted, like the firmware that are on them get corrupted, and then the machine doesn't work. So We could just program it and maybe that fixes it. Since that no longer looks like it is a burn. What do you think? Does it look like a burn? I don't know. It's like I'm not convinced one way or the other. Because usually when it's a burn hole, it's a burn hole. So I mean, I definitely see some sort of mark there, but I don't know. Anyway, I'm just gonna program it first and then we'll go from there. Let's do that. All right, so here's my programmer for my EC chips. So this is gonna be a SAS programmer, and then I have some of these PC Byte. These are probes that allow me to, instead of having to solder wires to the board, I can just set the probes there and it communicates with the debug headers. And so this SAS programmer, I'll show you what the part number is here because I can't pronounce the name. This is this programmer right here. It's made in Turkey. You can program through the keyboard headers. This board doesn't have a keyboard header programmer. And then here's the exact model. So you can do ITE, E&E chips, which this is an E&E chip, Novaton, and some other ones. Anyway, so I use this one quite a bit for programming all the E&E chips. And it's pretty straightforward, but it still is complicated. So let me just mount the board in here just like this. What we're gonna be looking at here is the debug header. And so here's the EC chip, and then we actually have some pins here that we can hook our programmer to. And they connect, I think it's this one, this one, this one, and this one. These four are where they actually connect. And I could show you, I have a diagram here. There you go, it's in that orientation. So here's our EC chip, and we are going to connect to these 4 pins right here. And this one is the enable, which would short the ground, but on this machine you don't have to do that. It works just fine without having to short that to ground. But we're just gonna connect across those 4. And here's actually a closer shot. This is just a cheat sheet that I have here. So each one of these wires are different colors. So I have blue, yellow, purple, and green. This, you can actually hook here. It does hook over to this pin. And we can look at that and how it's set up, but that's just an easier way than having to put them all close together. So this one right here, you see how it routes across over to here. So we'll be able to put a probe here, here, and here. All right, so the first one is, we'll do blue. So we're gonna take one of our probes and I'm just gonna set it there. And then I'm gonna hook my blue wire up to it. All right, and the next one is gonna be a yellow, and it starts getting tight pretty quickly, so we have to figure out a way to spread this out. Okay, and the next one, purple, but we're gonna skip the third one because we're gonna connect that one all the way over to, on the far end. So the next one over is gonna be purple. And purple's gonna be here. These things are so delicate. They wanna move very easily. Okay, and the last one is the green one. All right, so I have all 4 of them hooked up. I need to make sure to hook up our grounds. Okay, ground wires are hooked up. Next thing we need to do is we need to plug this into the computer. Okay, so everything's kind of wired up here. I plugged in the actual reader. We need to pull up the program to see if we can get it to detect. So we're gonna select our E&E. There we go, and we need to select our motherboard now. And this motherboard is gonna be the, uses a 9542GF chip. And because we're connecting it in a way that it's like we're soldering it on the board, you use selection of solder, and we're gonna send that programming to the programmer. Okay, so now that what we did is we basically selected the board that we're gonna be programming to, the type of chip we're programming to, the size of the chip, and then sent that to the programmer. Now I need to check connection, and we are getting an error, okay? The reason why we're getting an error is because we don't have the board powered on. So now I'm gonna power the motherboard on. I'm just gonna plug it in. So I plug in the DC jack here. And so you can see I tested connection, it works. So now we're gonna read it, and we're just gonna back up the data that's in there. And so it looks like this EC chip is actually working just fine. It probably just has a bad corrupted programming. And so because we're able to read it, we'll just flash it with a new piece of firmware, and then that should fix it up. And I actually already have a new version of the EC programming, so I'm just going to select that, and then we'll get that programmed right on there. And then this should actually fix the board up. Hopefully. This is just we're basically having to test certain things, try to figure out if the EC chip is bad or not. A lot of times it is just a programming issue. I rarely see a hole in the board. You would actually see it worse than it was. I mean, because that kind of looked like a burn hole, but we were able to scrape it away. It errored out. Data was written incorrectly. So let's try it again. I don't want to move because those pins are maybe not making good enough connection, and it might have made it where it had a reading issue. Okay, perfect. All right, so we can now test to see if the board power is on. So let me unplug the charger here. Let me get all these probes off of here. Okay. So all we have to do to determine if we've resolved the issue, we'll plug in the charger. We got 0.01, and this one doesn't have a power button on the board, does it? It doesn't. Okay, so we're gonna have to try to trigger it on. Let me get it out of this jig. Because if this doesn't work anyway, we're gonna have to pull the EC chip and put a new one on. So we have a power button somewhere around here. Oh, here's the power button. I guess one thing we can test to see is if we're actually getting our main power rail now. Let's see. Haha, our main power rail. Look at that. We are getting our main power rail now. So this board is most likely going to come on. So here's the power button. Where's it at? There's the power button. And if we can find the 3-volt line, which should be the second one maybe. So 3.2. So if I short these two together, we should get current draw on our meter here. 3, 2, 1. There we go, 1.84, 2 amps, and it's booting up. All right, so we are getting a different result than we had before. Originally, the board was dead. We were able to read their EC chip, which confirmed that the EC chip was actually functioning still. We wrote a new version of the firmware to the EC chip, and now the board's actually looking like it wants to turn on. And I'm glad that we didn't replace the EC chip because it was going to be a lot more work for no reason. Let me get this board installed and see if it resolves the issue. All right, I got the laptop reassembled. Let's plug it in and see if it does power on. And we got 0.01, 0.21, that's charging the battery, 1.9, 3.6 amps. So we're charging the battery, which is good news. Let's see if it will post. So I'm pressing the power button. Nothing's happening. It's because I forgot to plug in the power button ribbon cable. I got the laptop reassembled. Let's go ahead and plug in the charger and see what it does. It is pulling a little bit of current and see if it, I just want to see if it jumps up and starts charging the battery. 3.64 amps, perfect. All right, so that means that it is charging the battery. The machine's not actually coming on yet. Let's press the power button. And we got the keyboard backlight. We got the keyboard backlight. All right. So it's going to go through a little startup process. Let's see if we do get an Alienware screen. And I see the Alienware screen, but it is faint. I see it right here. We're getting a faint image. Now, what does that mean? Does that mean that someone's been messing with this and messed up the LCD connector, burned out something on the board? Oh my gosh. Oh God. And we're booted to Windows. I can hear the boot up sound, and I can see the clock faintly on the screen here. You see right there, it says what time it is. Yep. So we have a bad backlight now. So why is that? It's either the connection of the LCD, or it means they burned out a fuse or something like that on the board. So back to the drawing board. Oh, now we're getting psychedelics. Did you see that? Okay, let me check the LCD ribbon cable connection. And turn this back off. Let me unplug the battery. So because it did power on and start flickering, that probably means that the fuse is fine, but is there an issue with the cable? So I have the battery unplugged. You always want to unplug the battery before you mess with anything on here. This connector looks okay. It's a little bit loose, but let's plug it back in. Let me make sure it's securely in there. All right. Lock that in there. Make sure we don't have a cable issue. All right, let's try this again. I have the battery unplugged, so this is just going to be the charger only. Got the keyboard backlight again. Screen flashed for just 1 second. And do we have a screen issue? It's booting the Windows. I can kind of see it on the faint image, and the screen's flashing on for a second. I think we have a bad ribbon cable. If I touch the cable here, it flashes for a second. Or is it the screen itself? So we're gonna have to grab another assembly here and test it with another assembly. I'm thinking we might have a bad screen actually. So let me go grab a test screen real quick. All right, I grabbed the test LCD from our test machine. Let me get that hooked up. Just need to figure out if this is the motherboard that's doing this or if it's an LCD issue. I got the battery unplugged. Test LCD is connected. And let's see if it displays properly. The machine's coming on. And we are still getting a flickering issue. Interesting, okay. Well, let's, I did see that we are in manufacturing mode because we flashed that new EC chip. So let me get us out of manufacturing mode, see if that will fix it. Now, we may need to flash the BIOS or update something like that because there's a motherboard issue now, but we don't know why. Now the power button's not doing anything. Oh, there we go, okay. FNX. Okay, we got it out of manufacturing mode, which is basically whenever I flash the EC chip new, it does that. Let me see if I can adjust the brightness and see if this fixes the issue. That's not changing anything. Let me boot to Windows and see if we can adjust the brightness there. This could still be that bad EC chip. That spot could still be a burn in it, and maybe it had something to do with him unplugging the LCD screen. Unplugging the LCD screen with it on, and maybe it's sent, because this is in charge of the brightness of the screen too, the EC chip, so we definitely could have an issue with the EC chip. We still have to change it up. You know, it's funny, is I'm looking at the video here and you're having it kind of wave, it's actually flickering at a rapid rate right here. So you can't even see that what it's doing, but it's actually flickering like this, flick, flick, flick. So you're seeing it kind of wave on the video, but it's actually going like that. And let me adjust the brightness. The brightness isn't doing anything. There we go, I dimmed it. But right as I brighten it up, it stops working. So PWM signal's messed up somewhere in there. So if I go all the way to the dimmest, then it actually sits okay, and then right as I brighten it up, it starts flickering. So we have an issue with the board. And I'm kind of thinking it might have an AC issue. But let's look over here. I'm going to unplug the battery again. Let me take a look and see if we see anything on that PWM signals. So PWM stands for pulse width modulation. So what happens when you're brightening and dimming a screen, it actually is sending pulses of a signal. And so it'll be on and off, on and off. And the longer that it's on, the brighter it is. And the longer it's off, the dimmer it is. And so that's going to be all controlled in this area over here. I don't think this is a burn. I think this is just a pin 1 knot, a little notification there. That's a pin 1 spot. This is crooked, strange. We should check some fuses over here too. Right, we have FV, stands for fuse. I don't know if it's this one or this one. Usually when it's written this direction, it would be a component in that direction. But so I think this is the fuse right here. And this isn't measuring anything. I think that's actually a capacitor. And then there should be another fuse over here somewhere. Okay, so yeah, I'm gonna have to think about this. I kind of want to see what the signal looks like with it flickering like that. Or, you know, could it be a connector issue? I don't think it's a connector issue. All right, I'm looking around this board a little bit more. So the LCD connector's over here. I thought that this actually handled the PWM, but it looks like it's over in this area. I believe these chips are handling the PWM signal for the backlight's brightness. But what I just found was that. Do you see this? That looks like a burnt resistor. I'm in continuity mode right here. I'm just going to try to measure. So this one right here is measuring at 0.1 ohms, or 0 basically. And this one's measuring at nothing. We are in line. I know that you're not supposed to measure resistors in line, but we're not trying to get a measurement. But this should actually have a value, and it's measuring it open. Let me measure just a straight resistance mode, see if we actually have a value here. 50k ohms. Let me see if I can figure out what value that's supposed to be. Okay, so that actually might be okay, measuring at 50k. I mean, it really does look like it has a hole in it. You know, because again, when we're measuring this, we're measuring across a bunch of different things. So we could have multiple things in parallel on that same power rail or whatever it is. And so I just thought it looked a little suspect, but I think we're okay with that one because I think it's supposed to be 100K. So there could be another one in parallel with it, which would make it 50K. So that's fine. But so here's our area that we were looking at, and I don't see any damage on any of those chips. And I need to figure out how they're connected and see if I think they're run by the EC chip. All right, definitely a strange issue. I want to figure out if it's firmware related or if it's actually the motherboard itself or the EC chip itself. What I want to do next, before we start doing anything drastic and start changing out a bunch of chips and guessing and doing things like that, let's go ahead and flash the BIOS with a fresh BIOS that will rewrite the EC chip again. We want to make sure that maybe the EC chip, the version of the firmware I put on there is a little bit different than what is already on the board, and so maybe it's doing a conflict. So let's go ahead and flash the BIOS with a fresh full version, and then we can continue, because you never know. It could just be a firmware issue, and I hate doing things that we don't need to do. All right, I got the new version of the BIOS on here. We're just going to boot up and flash it. And there's a possibility, because whenever you flash an actual BIOS, there's like the BIOS region and there's the EC region. So we're going to see if we can get it to update. It is blinking pretty fast. It's hard for me to see, but I think I can figure this out. BIOS flash upgrade. I don't know if you can see it flashing, but it is flashing for me. And there's a chance that the battery is actually too low and I have to let it sit here and charge. But we will see. Yeah, I'm thinking the battery's too low. But we can see the current version of the BIOS at least. It's 121. And I'm putting on there 128. So it is a lot newer, probably a year or two newer actually. So there is a chance that this is just a firmware issue. Here, I'm going to see if I can just flash it within Windows. Save me a step. Okay, it says the tool will force suspend BitLocker. Perfect. Start BIOS flash. So the issue with me flashing it outside of Windows anyway was actually going to be where it overrode their BitLocker key. They were going to have to go through BitLocker recovery. So the fact that we were able to boot into Windows and actually flash it there, that saves them a step in the end here. So I'm going to let it run through this BIOS update, and hopefully that will fix the issue. If not, then we're going to end up pulling that EC chip anyway, putting another one on, and then having to reprogram it. So hopefully the firmware will match and it will work right. I don't know. And now it's writing the new ME region. So after it did the main BIOS area, it's doing the ME region, which is the management engine for Intel. Only Intel machines are going to have that. And I have seen where we have screen issues with that area being messed up. So if we had a corrupted firmware, EC firmware, then I guess there's a chance we have corrupted ME firmware and other firmware, but the machine happened to be turning on still after that. So maybe they were in the middle of a BIOS flash and this thing failed. All right, the machine is done updating. Now, is it going to come on and the screen work perfectly? I hope so. It's rebooting. And nope, still got a flicker. So still hardware, right? Is it the EC chip itself? I don't know. We're gonna have to investigate. It's not the cable, it's not the screen, but is it the connector? So let me unplug the battery again. We'll just press down and see if we can make better contact with some of these pins. I really don't think it's this connector, but we might as well try this. So a good thing to do is I just use the back of my tweezers here, and I just roll across here, or slide across. And that will just help make better connection, if that's what it is. There is a chance that it's just a bad chip, or they're getting a bad signal. It's like looking at this stuff, this is like sticky stuff, by the way. So it's not a burnt chip. We will reconnect this. Try it again. Nope, still flickering. Okay, back to the login screen. And I'm just playing around with the brightness again. So if I put it all the way bright, it flickers a lot. If I go down to a lower amount, it's not really flickering as much. It stays a little bit dimmer, but it's on. Well, you can still see it flickering in the video, but it's definitely not flickering as bad as that's all the way bright. So something's up with that PWM, and we're gonna have to measure it with it on, which is gonna be a little bit more difficult. And the question is it an EC issue still? Is it this chip? Is it that mark? Can't really even see that mark anymore. Yeah, I really just don't think it is. All right, I'll keep looking around and I'll be right back. All right, I'm trying to figure out what's going on with this machine. So right now I have it booted up into diagnostics. I'm just kind of propping the screen open, letting it flicker. You can see it flickering here. Just keeping this open so the Hall effect sensor doesn't turn the screen off. So it is still flickering. And I have my oscilloscope set up, which is just this little miniature oscilloscope, simple, not fancy at all. And what I'm trying to figure out is the PWM signal having an issue. And from what I could tell, the PWM signal that tells the screen to come on is just fine. I was just measuring right here. This is going to be the 19 volts that powers the backlight. And if I measure there, you can see that 10 volts per division, so therefore that's 20 volts basically. So we're getting 20 volts on that line. This is the enable pin right here, and this is the output. And so if I measure the output though, look at this crazy chaos. So I'm going to put that in auto and see if it lines it up. Okay, look, we're getting 17 volts. So if I just measure with the voltmeter, I'll get 17 volts, but the oscilloscope's saying that I'm getting really dirty signal. This is the 19 volt or 20 volt power line that powers the LCD screen. So this is supposed to be just a flat signal. This is not the pulsing signal, okay? This should not be turning on and off. So I don't know if we have something that's pulling down the output here. So it's either the screen, which we tested another screen on there, or it's this component here. It could be this chip itself, because the input is fine. So this is the enable. We're getting 3 volts, or 5 volts, sorry, 5 volt enable. I don't know what this pin does. This is 5 volts also. So both of those are 5. Those are 20 volts going in. And then these I don't think are anything. And then this is the output. And the output's just dirty. You can see it going crazy again. So I don't know. I may just take this component off first, and that will isolate the LCD screen from it to see if that fixes it or not. See if we still get if we get a clean signal. I don't know if we have something else that's pulling this signal or making the signal crazy. We could have another component that's tied to this, maybe one of these capacitors. Decoupling capacitors are partially shorted or something. Because if I measure there, let's measure on the back side of these. Those are measuring fine, but over here is crazy again. Right? So look at this signal. See that? So this is supposed to be just a constant 20 volts. So let's remove this component right here. On the schematics, it shows that there's a fuse right here, but that fuse is not populated. I don't know if we have a messed up inductor. That'd be kind of strange. But let me remove that and we can test. I have the battery unplugged. Everything's out of the system. One thing to look at, Because we should get 20 volts straight to that line with the machine off too. Let me measure that actually. I'm going to plug in the power. Let's put our meter in voltage mode. I'm going to measure right here the output of this. Plug in. And we don't have anything on there, that line. So is that the main 20 volt line? Yeah, so that's the main inverter power right there. You see these 4 pins that all go together? 1, 2, 3, 4. So this should be the 20 volts with the machine off. And I'm not getting anything there. Do we have the 20 volts here? Yep. I need to reflow the solder. I'm testing at this test point so many times. Are we getting this enable here or not? Although the lid is closed. Let me open the lid. Okay, so now the lid is open. No 20 volts there still. All right, so, but we do have our 20 volts there. Let me turn the machine on and then we'll turn it back off because when I unplugged all the power from the machine, it reset the EC and the BIOS and stuff, so we need to get that going. Because the whole thing about unplugging your LCD ribbon cable while you're working on it is because it keeps the inverter voltage straight to the screen always there. Ah, the screen's unplugged. Forgot. Okay, so let's plug the screen back in. So because the LCD is unplugged, I think it's not sending any voltage there. So I'll have all the power out of the system. There we go. All right, so now let's measure it with the machine off. And I just want to see if it's a dirty signal with it off. That's what we're trying to figure out. So I'm measuring right here. Plugged in the power. Not getting anything still. Got our 20 volts there. Yeah, this chip must have an issue, but we could have something pulling down. All right, let me just unhook this inductor real quick, and that way we can isolate it. The screen should still power on. It will just get no backlight at all, but then we can at least see if it's dirty or not. So what I'm going to try to do is just tombstone this up, which means I just want to stand it up on end. There we go. There we go. So I just got it lifted up so it's out of the picture. And now we can turn it back on again. Let me reconnect this LCD screen connector. Plug it in, turn it on. So if we look, we got 18.6, but it's moving around, which is strange, right? We got 19.8 going in. Let's look at it on the oscilloscope. So clean signal going in. Sawtooth going out. Look at that. Huh. Okay. Sawtooth. I wonder why it would give a sawtooth. Let's measure with resistance on this area right here. I want to see if we have some sort of partial short or something like that. So I am in ohms mode. 0.22 mega ohms. That's measuring to ground. A lot of times these are decoupling capacitors, so they should have ground on one side and positive on the other side.
All right, sorry about that. I forgot to turn on my main microphone. All right, so the next plan of action is we're going to go ahead and replace this component right here because the signal on the output should be cleaner than it is because this should just be a simple on-off, like a gate switch. And since we're getting some sort of discrepancy there, we'll go ahead and get that replaced. It's going to be simple enough. I don't have any new ones, but I do have one on one of these donor boards. So I'm just going to grab one off of here and get that transplanted. I'm not going to remove the motherboard this time, so we're just going to try to protect everything. The only thing that's close is this heatsink, so we will put some Kapton tape on there to protect that. All right, now that I got the area protected, let's go ahead and pull this component off. All right, we got it removed. And now, while it's hot, I'm just gonna put some fresh leaded solder on here. All right, let me grab the other one off the donor board. All right, here's our new one. And let's see, pin 1 is on this side, pin 1's there, so we're just going to flip this around. Okay, there we go. Okay, we have the new one installed. Let me clean up the area just a little bit. All right, I'm not sure if it's going to be any better than it was, but we will see. It would be nice if it's just that component. So let me plug our LCD back in. And if you noticed, when we soldered that, it actually soldered this component back down, so that is reattached. So we have a new one of these chips here. And let me hook up our oscilloscope again. All right, oscilloscope is reading nothing. Let's plug in the power. So now we have, I don't see anything showing up on there yet. Let's turn on the machine. When I turn this on, I have to kind of prop it open. I guess we can just turn it on and just take a look at the screen without trying to look at the signal. All right, let's turn it on and see if it works now. Got the power button, and look, the screen is resolved. All right. So there you go. We were able to resolve that issue. It ended up just being that component. I'm not really sure what caused that thing to blow out, but there was, you know, talking to the customer on the phone, he said he plugged in his power bank trying to power on this machine through the USB-C. I don't know if it backfed the system at some point, but remember that chip is on the main 19-volt power rail. It's always active whenever it's trying to power the inverted backlight. So it obviously got damaged, but we were able to resolve the issue, and I'd love to know your thoughts on this one, and thanks for watching.
I saved another laptop!